All right, strap in everyone for another deep dive.
Yeah.
This time, we're heading to a place that sounds like pure science fiction.
Hmm.
A metallic asteroid, the one and only 16 Psyche.
This sounds interesting.
But what makes this giant chunk of metal, just hurtling through space, so fascinating?
I'm all ears. Tell me more.
Well, some scientists believe it might actually be the exposed core of an ancient protoplanet.
Wow.
Like, imagine looking into the heart of a planet.
Yeah.
Something we can't even do here on Earth.
Makes sense.
But here's where things get really interesting.
Go on.
There's this almost gold rush vibe around 16 Psyche.
What do you mean?
Whispers of it being a potential gold mine.
Really?
Loaded with valuable resources.
Like what?
Think iron, nickel, and maybe even
Right.
precious metals like platinum and gold.
That's incredible.
So today we're going to dive into the feasibility of asteroid mining.
That's a great topic. I'm excited to hear more.
Put yourselves in the shoes of a decision maker. What would you absolutely need to know before investing in this kind of cosmic venture?
So let's break it down.
Yeah.
Let's start with 16 Psyche itself. What's its deal?
Yeah, first things first. What is this metallic asteroid all about?
All right, so the first thing to understand is its composition.
Obviously.
As you said, we're talking primarily iron and nickel,
Mhm.
which, that's what we believe planetary cores are made of.
Yeah.
But what really gets everyone excited,
Yeah.
the truly tantalizing possibility,
Right.
is the potential for precious metals,
Ah.
like platinum and gold.
Platinum and gold, the things that make everyone go crazy.
Exactly.
Okay, so we've got this
Right.
giant metallic treasure chest floating around in space.
Yeah, that's one way to put it.
But how giant are we talking exactly?
I mean,
Can we even fathom mining something that massive?
well, when I say giant, I mean giant.
Okay.
16 Psyche is roughly 226 kilometers in diameter.
Whoa.
Imagine the distance between Washington, D.C. and Philadelphia.
That's a huge distance.
That's the scale we're dealing with.
Wow.
And of course, that kind of size means a mind-boggling amount of metal.
Yeah.
Now, whether or not it's actually mineable,
Right.
that's exactly what NASA's Psyche mission aims to figure out.
The Psyche mission, yeah.
Yes,
It launched back in October 2023, right?
that's right.
And it's not expected to reach 16 Psyche until 2029.
Yep, a long journey ahead.
That's a seriously long trip.
It is, and that's precisely why the mission's technology is so crucial.
Right. So what tech are we talking about?
They're using what's called solar electric propulsion.
Solar electric propulsion, huh?
Yeah, so basically you have these massive solar panels
Right.
powering these incredibly efficient ion thrusters.
Mm.
These thrusters are perfect for these long hauls through space.
Right, because it's not like you could just pull over for gas.
No, not quite. And think about it. Any future mining operation,
Yeah.
it would need a reliable way to transport all those materials, right?
Makes sense.
And Psyche is like a test run for this kind of technology.
It's like a proof of concept.
Exactly.
So a super long journey, but at least we've got the sun to power it.
Yeah, the sun's got our back.
But once they get there, how do they actually figure out what's inside 16 Psyche?
Oh, that's where it gets really cool.
Yeah.
One of the key instruments on the Psyche spacecraft
Okay.
is a gamma ray and neutron spectrometer.
Gamma ray and neutron spectrometer. Big words.
Basically, it's a high-tech metal detector.
Ah, okay. Like a cosmic metal detective.
Exactly. And it allows scientists to analyze Psyche's surface composition right from orbit.
Wow, that's amazing.
It detects these unique signatures of different elements when they're bombarded by cosmic rays.
Mm.
So by analyzing these signatures, they can actually map out the distribution of different elements.
Wow.
Your iron, your nickel, and of course those precious metals we talked about.
Yeah.
They're basically creating a treasure map, but for an asteroid.
I love it. A treasure map for space.
Right.
So they're mapping out all the good stuff.
Exactly.
But are they trying to understand what's going on beneath the surface too?
Absolutely. That's another crucial aspect of the mission.
So how do they do that?
Well, besides the spectrometer, they'll also be using other instruments to study Psyche's magnetic and gravitational fields.
Interesting.
This data helps scientists create a 3D model of the asteroid's interior.
Oh, wow. Like an X-ray vision for an asteroid?
Exactly, you're getting it. It gives us insights into its structure and density, helping us peek beneath the surface and understand its internal makeup.
This is incredible. We're learning so much without even touching down on the asteroid.
I know, right? It's amazing what we can achieve with modern technology.
It really is. But let's get back to the million-dollar question. Can we actually mine metallic asteroids like Psyche.
Right, the big one.
Is this a sci-fi fantasy, or could this actually become reality?
That is the question, isn't it?
Yeah.
And the Psyche mission is a giant leap towards figuring that out. By collecting all this detailed information about Psyche's composition, structure, and resource distribution, the mission provides the data we need to really assess if mining is even feasible.
So Psyche's like this big, valuable test subject for all these space mining technologies.
Precisely. It's paving the way for the future.
That's incredible. But I think what everyone's really wondering is, how much is all this metal on Psyche actually worth?
Ah, the big money question.
We're potentially talking about, like, reshaping entire industries.
You're not wrong. The economic implications are mind-blowing, to say the least.
Yeah, I mean, just imagine the sheer amount of iron and nickel alone. If we could harness even a fraction of that.
It would be a game changer.
Right. Like, think about the impact on construction, manufacturing.
Every fact.
Even the prices of everyday goods could change dramatically.
Absolutely. It would be a seismic shift in global markets for those metals.
And we can't forget about the precious metals, the platinum and gold.
Oh, yes. The shiny stuff.
The stuff that makes everything go round. Electronics, medical devices.
Catalytic converters, jewelry.
It's everywhere.
Exactly. And platinum group metals especially are in such high demand here on Earth.
And so rare.
Right. That scarcity is a big driver of their price. Now, imagine a world where we suddenly have access to a vast, completely untapped source of these metals, all from space.
It's mind-boggling.
It is. It could revolutionize industries, maybe even make vital technologies way more affordable and accessible to everyone.
It's a pretty amazing thought. But,
What's that?
it feels like we're getting a little ahead of ourselves.
Oh, how so?
We keep talking about all this amazing technology, the potential money to be made.
Yeah.
But what about the challenges? I mean, extracting and processing metals in space?
Yeah.
It can't be a walk in the park, Riley.
Oh, you are absolutely right. We need to be realistic here. There are some serious hurdles we need to overcome before asteroid mining becomes a day-to-day reality.
I bet.
Working in low gravity, millions of kilometers away from Earth.
It sounds tough.
It presents a whole new world of engineering challenges. Just think about it. Anchoring equipment, handling all those materials.
Right.
Protecting workers from radiation and micrometeoroids. It's a lot to consider.
That's a lot to deal with. And then there's the cost factor. These missions aren't cheap.
Definitely not.
Investors are going to need some serious convincing to get on board with this.
You're telling me the economic viability of asteroid mining is a make-or-break factor. We need to figure out efficient, cost-effective methods for everything.
Right.
Extracting the resources, processing them, transporting them back to Earth.
Or even just using them directly in space.
Exactly. All of that needs to be figured out.
That raises another interesting point, the legal stuff. The
Yeah.
ethical side of things. Who owns these resources floating out there? What rules are there for space mining?
You've hit the nail on the head. These are crucial questions. And honestly, the current legal framework for space resource use is still very much in development.
I can imagine. So are we basically operating in a legal gray area?
Kinda. See, there's the Outer Space Treaty signed way back in 1967.
It
It says nations can't claim ownership of celestial bodies.
Okay.
But it does allow for using space resources. The problem is the treaty isn't super clear on the specifics of commercial resource extraction. There's a lot of debate about how it applies to activities like asteroid mining.
So we need more clarity then.
Yeah.
Clearer rules of the road to ensure responsible and fair access to space resources.
Exactly. We don't want a space free-for-all. And beyond the legal aspects, there are the ethical considerations too.
For sure. So what kind of ethical dilemmas are we talking about?
Well, for one, we need to carefully consider the potential environmental impact of all this. Could our mining activities disrupt some delicate ecosystem out there? Could we create more space debris that poses a danger to other spacecraft?
Those are good points. Definitely things we need to think about before we start digging into asteroids.
Absolutely. It's a complex issue with lots of moving parts.
It seems like the Psyche mission is at least helping to start the conversation about these challenges, which is a good thing.
Definitely. It's a step in the right direction.
Now, earlier we mentioned the OSIRIS-REx mission, which brought back samples from the asteroid Bennu.
Right.
How does that mission compare to Psyche?
Good question. OSIRIS-REx was groundbreaking in its own right, but it had a different focus.
In what way?
Well, while Psyche is all about exploring a metallic asteroid, OSIRIS-REx targeted a carbonaceous asteroid.
Carbonaceous asteroid. What's that?
It's a type of asteroid rich in carbon and organic compounds.
Interesting.
OSIRIS-REx was mainly about collecting samples from Bennu
Okay.
to learn about the origins of life in the early solar system, less about resource extraction, more about scientific discovery.
So two different asteroids, two very different goals.
Exactly. It's like comparing apples and oranges.
But they both add to our understanding of the universe, right?
Absolutely. They both highlight the incredible diversity of objects out there in space.
Yeah.
And speaking of learning from different approaches.
Yeah. What about past attempts at asteroid mining?
Oh, right. Like that company, Planetary Resources. What happened to them?
Planetary Resources, they were pioneers in the field.
They were.
Sadly, they eventually shut down, but they taught us a lot.
What kind of lessons did they offer?
Valuable lessons about the sheer complexity and the challenges of this kind of endeavor. They showed us the need for solid economic planning, innovative technology, and a deep, deep understanding of the space environment.
So they really helped lay the groundwork for future attempts.
They pushed the boundaries, that's for sure. And it's a reminder that even failures can teach us valuable lessons.
Absolutely. Failure is often the best teacher. So what can Psyche specifically teach us about the future of asteroid mining?
Psyche's findings will be so valuable, especially for understanding other metallic asteroids out there.
Makes sense.
The data could help us create a detailed map of potential mining targets,
Oh, wow.
each one with its own unique composition and resource potential.
So like a treasure map of the solar system. Exactly. But instead of X marks the spot, you've got a detailed analysis of each asteroid's metallic riches.
That's a pretty awesome concept, a treasure map of the solar system.
Right, but it's not just about finding the right asteroids. It's about developing the technology to get there,
Yeah,
and then to actually extract those resources efficiently and sustainably.
right, and doing responsibly.
Exactly. The advancements made for Psyche, like the autonomous systems and the advanced propulsion, those could be adapted and refined for robotic mining missions down the line.
That's pretty amazing to think about. It really feels like we're on the edge of a whole new era of space exploration,
I agree.
where we're not just observing things out there, but actually using what we find.
We're becoming active participants.
Right. And speaking of utilizing what we find, you mentioned something earlier about in situ resource utilization.
Oh, yes. ISRU.
ISRU. Can you break that down for us? What exactly does that involve?
Think of it this way. Instead of hauling everything we need all the way from Earth, we could essentially live off the land, but in space.
Live off the land.
Yeah, using resources we find right there in space.
That's amazing. So what are some examples?
For instance, we could potentially extract water ice from asteroids or the moon
Okay.
and use that to produce things like breathable oxygen, drinking water, even rocket fuel.
Wow. So it's like off-the-grid living, but on a cosmic scale.
Exactly. A
Yeah.
perfect analogy. And when you combine ISRU with 3D printing, what's also known as additive manufacturing,
Right, 3D printing.
things get really interesting. Imagine using asteroid metals to 3D print structures and tools right there in space, even habitats.
Wow. So we could build entire settlements using materials mined from asteroids.
It's a real possibility. The possibilities are pretty much endless.
That's pretty mind-blowing. But there's always
Exactly.
but, right. We have to remember those ethical and legal questions we talked about earlier.
Oh, absolutely. They become even more important as we start thinking about large-scale resource extraction and habitat construction in space.
It's not just about finding a space rock and claiming it. We need to think about the bigger picture, the implications for humanity and for space itself.
Couldn't agree more. You mentioned the Outer Space Treaty earlier.
Yeah.
Well, it's a cornerstone of space law, preventing countries from claiming ownership of celestial bodies. But it does allow for resource use.
Right.
The thing is, there's still a ton of debate about what that actually means when you get down to it, especially for commercial ventures like asteroid mining.
So it's a good starting point, but it needs some work.
Exactly. We need much clearer international guidelines to ensure fair access to these resources, to encourage peaceful cooperation, and to prevent any one nation or company from just monopolizing everything.
Sounds like we need a United Nations. But for space?
Maybe we do. But besides all the legal stuff, the ethical implications are huge too. We have to think about the potential environmental impact of large-scale mining.
Right. Could we accidentally mess up a delicate space ecosystem?
Exactly. Or create even more space debris that could be dangerous for other spacecraft.
That's a scary thought.
It's a big responsibility. As we venture further into space and start using its resources, we absolutely have to do so sustainably and ethically.
I agree.
We need to make sure our actions benefit all of humanity and that we're preserving space for future generations.
Okay, so we've covered a lot of ground here. We've talked about the technology of the Psyche mission, the potential profits from asteroid mining, the challenges we face,
A lot to unpack.
and the ethical and legal questions that are going to shape this whole new frontier.
It's a lot, but it's exciting stuff.
It is. Now, out of everything we've discussed, what gets you most excited about the potential of asteroid mining? What's the most compelling aspect for you?
That's a good question. I think for me, it's just the sheer audacity of it all. This idea that we could reach out into this vastness of space and tap into resources that could completely change our world.
It's pretty wild to think about.
It is. It's awe-inspiring. Imagine a future where we're not limited by Earth's resources anymore,
Yeah.
where we can build and create on a scale we've never even dreamed of.
It's almost like we're on the verge of a new industrial revolution, but this time it's happening in space.
You got it. A space-age industrial revolution.
It really does feel that way. And beyond the potential financial gains,
Yeah,
there's just the scientific wonder of it all,
that's what drives me. Each metallic asteroid is like a time capsule,
right?
holding clues about the early solar system, the processes that formed planets.
Amazing how much we can learn from them.
I know. Psyche, especially, it's this unique chance to study the heart of a planet.
Yeah.
We can't do that here on Earth. Who knows what secrets we might uncover as we explore these metallic worlds?
Maybe evidence of past life, new materials with properties we can't even imagine.
The possibilities are endless, and that's what makes this such an exciting time to be working in space exploration.
I can only imagine.
We're right on the edge of this whole new era of discovery and innovation, and asteroid mining is a major part of that.
Okay, so let's bring it back down to Earth for a second. Picture yourself back in that meeting about asteroid mining. You've just heard this amazing breakdown of 16 Psyche, the mission, the technology, the challenges, the potential. What's your takeaway? Is metallic asteroid mining a pipe dream, or is it a potential game changer?
Honestly, I'd say it's a bold ambition. It has the potential to revolutionize our world
For sure.
here on Earth and beyond. But like we discussed, it's not without its challenges.
Well, definitely not.
We have technological hurdles to overcome, legal frameworks to develop responsibly,
Right.
and we have to ensure we're doing all of this ethically and sustainably.
It's not as simple as grabbing some space rocks and calling it a day.
Exactly. It's going to take careful planning, international cooperation, and a commitment to using these resources to benefit all of humankind.
That's a good way to put it.
And the thing that inspires me most about the Psyche mission is that it embodies that spirit.
How so?
It's a testament to human ingenuity, to our drive to explore the unknown, and to our desire to push the limits of what's possible.
You're right. It's a good reminder that even the most audacious dreams can become reality as long as we dare to explore, to innovate, and to work together.
It's all about collaboration.
So, as we wrap up this deep dive,
Yeah.
what's one final thought you'd leave our listener with as they ponder the future of metallic asteroid mining?
Well, I'd encourage them to look up at the night sky and just imagine a future where humanity has expanded beyond Earth,
Okay?
where we're not just visitors in space, but active participants in this cosmic dance. A future where asteroid mining isn't just a concept, but a thriving industry,
I like it.
providing resources for a sustainable and prosperous future both here on Earth and among the stars.
That's a vision I can definitely get behind.
It's a future worth striving for.
It is. Thanks for joining us on this incredible journey to the metallic heart of an asteroid. We hope you learned something new and that you're as excited as we are about all the possibilities that lie ahead. Until next time, keep exploring.
It's a lot to consider, isn't it?
It really is.
But back to the economics for a minute.
Yeah.
The sheer volume of iron and nickel on Psyche is
huge.
yeah, like mind-boggling. If we
Well-
could somehow harness even just a fraction of that,
It would be.
a game changer
Yeah.
for sure. Think about what it could do to global markets for those metals.
Yeah, like
Just
construction.
manufacturing.
Yeah, all of that.
Even the price of everyday stuff could change dramatically.
Oh, yeah, for sure. And we can't forget
Right.
about those precious metals, the platinum and gold.
Ah, yes, the shiny stuff.
Yeah, the stuff that makes the world go round, you know, electronics,
Medical device.
catalytic converters.
Sure, it's in so many things.
Exactly.
Yeah.
And those platinum group metals, especially.
The demand for them here on Earth is through the roof, and they're so rare, which of course drives the price up even more.
Right.
But now imagine we suddenly have access to this massive untapped source of these metals. From space. It's mind-boggling.
It's crazy to think about.
It really is. It could totally revolutionize so many industries and maybe even make those really important technologies much more affordable and accessible for everyone.
That would be
incredible.
Amazing. It's a really exciting thought. But I feel like we're getting a little ahead of ourselves.
How so?
You know, we're talking about all this amazing technology, the money we could potentially make. But are we forgetting about the challenges? You know, actually extracting and processing those metals in space.
Oh, right. Yeah.
It can't be easy.
No, it's definitely not a walk in the park. We have to be realistic. There are some huge hurdles we're going to have to overcome before asteroid mining becomes an everyday thing.
Yeah. Like, how do we even begin to tackle that?
Well, for starters, operating in low gravity, millions of kilometers from home, that presents a whole new set of challenges for engineers.
Makes sense.
Think about anchoring equipment, handling the materials, protecting workers from radiation and micrometeoroids.
Yeah.
I mean, it's a whole lot to think about.
Yeah. And we can't forget about the cost factor.
Oh, absolutely.
Like, these missions are super expensive.
They're not cheap.
You're going to need some pretty convincing arguments to get investors on board with this.
100%.
Yeah.
The economic viability of all of this is
a make or break.
Make or break, yeah.
Yeah.
We need to figure out how to extract those resources, process them, and transport them back to Earth and do it all efficiently and cost effectively.
Yeah.
Otherwise,
it's not going to happen.
It's a no-go.
Yeah.
And on top of all that, we have the legal stuff to figure out.
Oh, yeah.
And of course, the ethical considerations.
Yeah, like, who even owns all those resources just floating out there in space?
Exactly.
And what are the rules for mining them?
Those are some big questions.
Yeah, they are.
And honestly, the current legal framework around using space resources, it's still very much in development.
Really? It's not very fleshed out?
Not really, no. Like, you've got the Outer Space Treaty signed back in '67, which basically says countries can't claim ownership of celestial bodies.
Okay.
But it does allow for using space resources.
Yeah. But that's pretty vague.
It is, yeah.
Right.
It doesn't really get into the specifics of commercial resource extraction.
Right.
So there's a lot of debate about how it applies to things like asteroid mining.
So we're basically in kind of a legal gray area when it comes to this.
Yeah, pretty much.
So we need clearer guidelines then.
Absolutely.
Okay.
We need something to ensure that everyone has fair access to space resources.
Right.
And that everything is done responsibly and that we prevent any one country or company from just monopolizing everything.
Yeah, that would be
not good.
Not good.
And then on top of all the legal stuff, you've got the ethical considerations too.
Yeah, what kind of ethical dilemmas are we talking about?
Well, one thing we have to think about
Yeah.
is the potential environmental impact of all of this.
Yeah, for sure.
Could all our mining activities disrupt some fragile ecosystem out there?
That's a good point.
Or could we end up creating even more space debris that could pose a danger to other spacecraft?
That's a scary thought.
Yeah, it's something we definitely have to consider before we just start digging into asteroids.
Yeah, we don't want to create a bigger problem while trying to solve another one.
Exactly.
Like a complex issue.
For sure.
With a lot of moving parts.
Absolutely.
But it seems like the Psyche mission is at least helping to start a conversation about these challenges.
Definitely.
Which is a step in the right direction.
It is.
Now, earlier we talked about the OSIRIS-REx mission.
Right.
The one that brought back samples from the asteroid Bennu. How does that mission compare to Psyche?
That's a good question.
Yeah.
OSIRIS-REx was a huge deal.
It was.
But its focus was pretty different from Psyche's.
Okay, that's so...
Psyche is all about a metallic asteroid.
Right.
OSIRIS-REx was about a carbonaceous asteroid.
Carbonaceous asteroid. I don't think I've heard that term before.
Yeah, it's a type of asteroid that's rich in carbon and organic compounds.
Interesting.
So the main goal with OSIRIS-REx was to collect samples from Bennu, to study the origins of life and the early solar system.
Okay.
It was less about resource extraction and more about scientific discovery.
So two different types of asteroids.
Yeah.
Two very different goals.
Exactly.
But they both add to our understanding of the universe.
Right. Yeah, comparing apples and oranges.
Yeah, they're both fruit, but
Right.
totally
They're
different.
totally different.
Yeah.
But they both highlight the incredible diversity of stuff out there in space.
Okay, so we've talked about two different missions.
Yeah.
Two different asteroids.
Yeah.
What about past attempts at asteroid mining?
Oh, yeah.
You know, like that company Planetary Resources?
Yeah. Planetary Resources.
Oh, whatever happened to them?
They were pioneers in the field,
Who were?
but they ended up shutting down.
They did. Why was that?
Well, it's complicated.
Yeah, I'm sure.
But they taught us some valuable lessons about how complex and challenging this kind of thing really is.
What kind of lessons did they offer?
Well, they highlighted the need for really solid economic planning,
Right.
really innovative technology,
Mm.
and a really deep understanding of the space environment.
So they really paved the way for future attempts.
Yeah, they pushed the boundaries, for sure.
Yeah.
And it's a reminder that even failures can be valuable learning experiences.
Absolutely. Sometimes you learn more from your failures
Right.
than your successes.
You do?
So speaking of lessons,
Yeah.
what can the Psyche mission teach us
Oh.
about the future of asteroid mining?
Psyche's findings are going to be so valuable,
Okay.
especially when it comes to understanding other metallic asteroids.
That makes sense?
The data from the mission
Yeah.
could help us create like a detailed map of potential mining targets.
Okay.
Each one with its own unique composition
Right.
and resource potential.
So we're talking like a treasure map
A treasure map
of the solar system.
of the solar system.
But instead of X marks the spot,
Right.
it's like a detailed analysis of all the best places to mine.
Exactly.
That's incredible.
But it's not just about finding the right asteroids. It's about getting there
Yeah.
and then extracting those resources
Mhm.
efficiently and sustainably.
Yeah. Doing it the right way.
The right way, yeah. The
Okay.
technologies that they're developing for Psyche, like those autonomous systems and advanced propulsion systems,
Mhm.
those could be adapted and refined for future robotic mining missions.
So it really feels like we're on the brink of this whole new era
It
of
does.
space exploration,
Yeah,
where we're not just looking at things out in space,
right.
but actually using them.
Exactly.
Or becoming active participants.
Yes.
Yeah.
And, speaking of utilizing what we find out there,
Yeah.
remember we touched on in situ resource utilization earlier?
ISRU?
ISRU?
Can you remind us what that's all about?
Sure. So ISRU is basically the idea that
Okay.
instead of bringing everything we need with us from Earth,
Right.
we could use resources we find in space.
So like living off the land.
Yeah, exactly. Like living off the land, but in space.
In space, yeah.
So, for example,
Yeah.
we could potentially extract water ice from asteroids or the moon.
Oh, okay.
And we could use that water ice to produce breathable oxygen,
Right.
drinking water,
Okay.
even rocket fuel.
Wow. So it's like off the grid living. But on a cosmic scale,
Exactly.
that's incredible.
And when you combine ISRU with 3D printing,
Okay.
also known as additive manufacturing, things get really interesting.
In what way?
Well, imagine using asteroid metals to 3D print structures,
Okay.
tools,
Right.
even habitats,
Wow.
right there in space.
So we could build entire settlements
It's possible.
using materials mined from asteroids.
Yeah. It's a pretty incredible concept.
It is. It's pretty mind-blowing.
It is.
But we have to remember
Yeah.
all those ethical and legal questions we discussed earlier.
Oh, absolutely.
Right.
Those become even more important
Especially.
when we start talking about large-scale resource extraction
Yeah.
and building habitats in space.
It's not as simple as just finding an asteroid
Right.
and claiming it.
Exactly.
It's not a free-for-all.
We have to think about the bigger picture.
We do.
The implications for humanity and for space itself.
Absolutely.
Right.
You know, the Outer Space Treaty.
That we talked about earlier,
Uh-huh.
that's kind of the cornerstone of international space law.
Right.
And it prohibits countries from appropriating celestial bodies.
Right.
But it does allow for using resources.
It does, but that's pretty open to interpretation.
It is.
Okay.
It's not super specific,
Yeah.
especially when it comes to commercial activities like asteroid mining.
So we basically need a more detailed set of rules.
Yeah, we need something more specific.
to govern all of this.
Exactly.
Yeah.
We need some clear international guidelines
Okay.
that ensure everyone has equitable access to space resources
Right.
and that everyone's cooperating peacefully.
Mm-hmm.
And that no one country or corporation can just monopolize all those resources.
Sounds like we need a United Nations for space.
Maybe we do.
Yeah.
But beyond the legal stuff,
Right.
we also have to really seriously consider the ethical side of things.
Like, what are the potential environmental impacts of this?
What could happen if we start doing large-scale mining operations in space?
Could we mess up some delicate ecosystem that we don't even know about yet?
Right. We don't know what's out there.
Yeah.
We could accidentally do some serious damage,
Right.
and we could end up creating a lot more space debris,
Right.
which could be dangerous for other spacecraft.
It's a lot of responsibility
It is.
as we venture further out into space
Mm-hmm.
and start utilizing those resources
We have to make sure we're doing it the right way.
sustainably and ethically
Exactly.
to make sure it benefits everyone
And future generations.
and that we're preserving space for future generations.
Right.
Okay, so we've covered a lot of ground here.
A lot of ground.
We talked about the technology,
Mm-hmm.
the potential profits from all of this,
Uh-huh.
the immense challenges we're facing,
Right.
the ethical and legal considerations.
That's a lot.
What for you is the most compelling aspect of all of this? What makes you really excited about the future of asteroid mining?
You know, for me, it's the sheer audacity of it all.
The audacity.
Yeah, this idea that we could actually reach out into the vastness of space
Yeah.
and tap into these resources that could fundamentally transform our world.
Yeah.
It's just awe-inspiring.
It's a big idea.
It is a big idea.
Yeah.
Imagine a future where we're not limited by Earth's resources anymore.
Right.
We could build and create things on a scale we've never even dreamed of before.
It's like we're on the verge of this new industrial revolution,
Yeah.
but this time it's happening in space.
Exactly, a space-age industrial revolution.
And beyond the economic potential,
Right.
there's just the pure scientific wonder of it all.
Oh, absolutely.
Yeah.
Every metallic asteroid is like a time capsule,
Yeah.
holding all these clues about the early solar system,
Yeah.
the processes that led to the formation of planets.
It's amazing.
It is.
Psyche especially offers this incredible opportunity
I know.
to study the heart of a planet.
Something we can't do here. So who knows what secrets we might uncover
Yeah.
as we explore these metallic worlds.
Maybe we'll find evidence of past life out there,
It's possible.
or discover new materials with properties we haven't even thought of.
Yeah. The possibilities are truly endless.
They are. It's so exciting.
It is. It's a really exciting time to be involved in space exploration.
For sure. Okay, let's bring it back down to Earth for a moment.
Back to reality.
Imagine you're in that meeting about asteroid mining.
Okay.
You've just had this deep dive into 16, Psyche, the mission, the technology, the challenges,
Mm-hmm.
the potential, everything.
Okay.
What's your takeaway?
My takeaway.
Yeah.
Well, I think metallic asteroid mining.
Yeah.
It's a bold ambition
Okay.
with the potential to completely revolutionize our world.
It could change everything.
It really could,
Yeah.
both here on Earth and beyond.
Right.
But like we talked about,
Yeah.
it's not without its challenges.
It's not going to be easy.
It's not going to be easy, no.
We've got technological hurdles to overcome, legal frameworks to develop,
Mm-hmm.
and we have to make sure we do it all ethically and sustainably.
It's a lot to consider.
It's a big undertaking.
It is.
It's not just about grabbing some space rocks and calling it a day.
It's fair enough.
It's about careful planning,
Yes,
international cooperation,
absolutely.
and a real commitment
Yeah.
to using these resources
Oh,
for the benefit of all humankind.
couldn't have said it better myself.
And I think what's so inspiring about the Psyche mission
Mm-hmm.
is that it really embodies that spirit.
It does.
You know, it's a testament to human ingenuity,
Yeah.
to our desire to explore the unknown,
That drive to push the boundaries.
to push the boundaries of what's possible.
It's really remarkable.
It's a good reminder that even the most audacious dreams,
Yeah.
they can become reality
Oh.
if we dare to explore,
Innovate.
innovate,
It
and
gets
work together.
all about collaboration.
So as we wrap up this deep dive, what final thought would you leave our listeners with as they contemplate the future of metallic asteroid mining?
I'd encourage them to look up at the night sky And just imagine a future where humanity has expanded beyond Earth.
Beyond Earth.
Where we're not just visitors in space,
Yeah.
but active participants in this grand cosmic dance.
I love that.
Where asteroid mining isn't just an idea,
Right.
but a thriving industry.
Yeah.
Providing resources for a sustainable and prosperous future,
That sounds amazing.
both on Earth and among the stars.
It's a beautiful vision.
It's a future worth striving for.
That's a future I can get behind. Thanks for joining us on this incredible journey to the metallic heart of an asteroid.
It's been a pleasure.
We hope you've learned something new
Me too.
and that you're as excited as we are about all the possibilities that lie ahead.
Absolutely.
Until next time, keep exploring.